to do now is we're going to start entering the topic of trig where we're approaching vectors and force. And this is a little prelude to physics, and of course physics and math is a little different, but we'll work through it. If you notice, these are what kind of numbers? No. What are they?
Imaginary.
They're not imaginary numbers. That's an imaginary number. What's 1 plus 5i? Complex number. Complex made up of the reals and the imaginaries. So now, they may ask you this on the Regents exam, they may not. It is such an easy topic, though, that I don't want to miss out on it. So that's what we're going to do. First thing we have to do is express the sum of z1 and z2 as a complex number. All you got to do is add them together. So we'll take z1 plus z2. I don't think we have to do too much work. What's 1 plus 6?
7.
Great. And what's 5i plus 2i?
7.
Great, there's our sum. Add the reals with the reals, imaginaries with the imaginaries. Now, graph the sum, z1 and z2. That's what you have to do. Okay, so we've never graphed complex numbers before. We've only graphed real numbers. Real numbers get graphed on the x, y plane, called the coordinate plane or the Cartesian plane. There's no real y. Y rhymes with I. So now when you make your plane, this is called the argand plane, A-R-G-A-N-D, argand plane, xi. So when it's really important that you graph and you label x on the right, I on the top. So go ahead and do that, and then I'll show you how to graph. So with your straight edge, xi plane.
There's no little.
There you go. Use like side of your cup if you don't have to. Your planner. Planners came with a ruler. If you want to go down to Carol's, she might have an extra. So you can see how to do this. It's really easy. Start at the origin. I need to graph 7 on the x because that's the real number. 1, 2, 3, 4, 5, 6, 7. I'm off my grid wheel. And then I have to go up on the I, 7. 1, 2, 3, 4, 5, 6, 7. So I didn't make my grid big enough. And I'm going to put a dot. So I went to the right 7, because this represents the x-axis. Then I went up 7 on the I-axis. Now here's the unique part, which is different. All it is a point right now. However, when we graph complex numbers, it's actually a vector. And a vector in science is an arrow. So I'm going from the origin to the point. I cannot make my arrowhead go past the point. The arrowhead has to sit right on that point, please. Don't make it go past. And then this is called the tail down here. And this is the head. Where do you see vectors in the real world? Vectors are the arrows. Where do you see them? You watch Weather Channel? Any kind of weather station?
Like wind direction?
Wind direction. You've been doing wind direction since 5th grade. Anytime when you've got that northeast flow with the jet stream, and they'll show where the wind's coming from or where it's out of, those are all vectors. They're used, pilots use it all the time, used in weather all the time. It's that simple. That's all you have to do. That's all it is. So I've got a couple for you to try in a minute. Vectors have direction and magnitude. So you need to write this down. This is going to help you when you hit physics. They have direction and magnitude. The tail, we already talked about. And then the head is the arrow. Do you know what the synonym for magnitude is? Speed. Speed. How fast? So magnitude, how fast, how much, how does it weigh? Okay, so now, We're going to start solving a problem using vectors. Very first thing you have to do every single time is create a parallelogram. Most important thing. And you need a picture every single time. So we've got two forces of 28 pounds and 41 pounds acting on a body so that the angle between the two forces measures 72 degrees. Find to the nearest tenth of a pound the magnitude of the resultant forces produced. Are you kidding me? Can you even make sense of that? Yeah. So, Carly, can I steal you for a minute? You can stay right there. Can you put one of your hands up? Clean them all up. So here's what we're going to do. We're going to be forces. So I've got a force, and I'm going to be the 41-pound force. And she's going to be the 28-pound force. You're going to parallel. Now, she and I are going to push against each other because we're forces. Who's doing it? Why? I have more force, plus I'm in a standing position. So, but what's happening here is I'm pushing, she's pushing, I'm going to move closer this way. So we're acting on an object which happens to be our hands. That's what's happening. But to make it simple in math, all we're going to do is start with parallelogram. Your forces are your sides. I don't care where you put them. One of the forces is here, one of the forces is there. But you know from geometry in a parallelogram, what do you know about opposite sides? They're congruent. So this is going to be force 1 and what's going to be up here? Force 2. Great. From geometry, what do you know about opposite angles? They're going to be congruent as well. So those are going to be equal, and these are going to be equal. What do you know about the opposite sides as well? They're parallel. Sometimes that matters. I'll just mark our parallel sides just in case. So that's why we draw a parallelogram. And then what we're going to do is we're going to plug in the information to that, and I'll show you what we're going to do. So we have two forces, 28 pounds, 41 pounds. All right, I'm going to put 28 for force 1. It doesn't matter. And I'm going to put 41 for force 2. It does not matter where it goes. Your choice. The next thing I'm going to do is those forces are acting upon each other. So I'm going to draw in what's called the resultant, which is your diagonal. Picture our hands. Here's Carly's hand. Here's my hand. We're acting and we're making some kind of movement here. So this is the angle we're operating on. So two forces of 28 pounds and 41 pounds act on the body so that the angle between the two forces measures 72. Find to the nearest tenth of a pound the magnitude of the resultant of the forces produced. Okay, so let me come over here. This is, and this is. So now, how do we figure out where we put this 72? Because it could be here, it could be here. Agreed? Most of the time, what you're going to do is, which ones have twos?
The one with the 2.
Right, so this is clearly a cube. I'm putting my 72 here. How do we find that one? Nice catch. How do we find this angle here?
72 plus 72 plus 2x equals 360.
We can do that. There's an easier way.
Subtract it from 1.
Subtract it from 180. These two are supplementary. Yours will work. It's a little longer. So it's 180 minus 72. 108. All right, so now my picture's pretty messy because I was switching this. So let me just pull out one of the triangles. So I have 41, I have 28, I have 108. Do you agree with? I just pulled the triangle out. They're the same. Just pulled one. I gotta find the magnitude of the resultant to the nearest pound. I'm not looking for an angle, I'm looking for a side. So this is what I'm looking for. Law of sines, law of cosines, or area? Law of cosine. Side angle side. So it's going to be law of cosines. And, oh, remind me to put my degree. All right, so now all we're going to do is work through this problem knowing law of cosines. Most of the time, once you get a parallelogram and a force, it's either law of sines, law of cosines, or could be both. All right, so we've got x squared equals 28 squared plus 41 squared minus 2 times 28 times 41 times cosine 108. Danny, there's the answer. Okay, let's look at another one. Oh. We talked about degrees and seconds, right? You know how to change this on your calculator? Let's do this one. Two applied forces produce a resultant force of 18.6 pounds. Smaller force measures 15.8, larger force 24.3. Finally measure the angle between the two forces to the nearest tenth of a degree. Okay, what do we have to start with?
Parallelogram.
Yeah. Okay. 18.6. 15.8.
So it says the resultant force. Wouldn't that be the
Oh,
ionic?
thank you. Yes, it is.
Yeah.
Thank you. So the resultant, thanks, Jacob, is 18.6. And smaller force 15.8. And larger force 20. We want to find the angle between. Whenever they talk about the angle between the two forces, we always want to go right to where that resultant is, because that's where the two forces are acting and they're applying the pressure, just like our hands. So this is actually what we're looking for. However, we don't know that the diagonal bisects. So we're not going to be able to go right there. We're going to have to utilize the obtuse angle and then subtract that from 180 to find that angle. Be very careful. That's a tricky, tricky problem. So whenever we're talking forces, we draw a resultant in. The angle that they're talking about is going to be where the resultant goes through. This is not bisected. So what you have to do is use the obtuse angle, get an answer, and then to find your answer, which is going to be down here, you subtract it from 180. So this is the angle we're looking for. What law? Law of cosines again. So we'll set it up. We're looking, I'll make that A so we can just have a reference point. So we have 18.6 squared. Do you see how these numbers are not pretty? Equals 15.8 squared plus 24.3 squared minus 2 times 15.8 times 24.3 cosine A. What's that?
That's just to find the obtuse angle when you can the other one, right? Or
Yeah. That's why we subtract it. Now, based on my picture, I thought I was finding the obtuse triangle. My picture was not drawn to scale. So I found this, and I was a little shocked when I looked at my picture, but I can't draw, so I don't worry about that. I need the other one, because I need the angle between the two forces, so I subtract it from 180. I get 130.1 degrees. This would be a 4-point question on the regions. 4-point. So, that's how we set it up. Let me advance the slides. And I'm going to give you probably one problem out of your book for homework instead of the notes.
we have smartphones.
Yeah, I can't take it.
Not applicable. Yeah, he didn't actually mail it to me.
Okay, so for homework, I would like you to on page 805, number 43. Page 805, number 43. That it's not this. I want to do a little more with you on this stuff before I give you the worksheet. This is old.